See, in this question, a figure shows a system consisting of a massless pulley, spring of force constant K, block of mass M. The block is slightly displaced vertically down from its equilibrium position. Find time period of SHM. Now, here as you know, gravity is a constant force. So whenever you displace, it won't contribute to any extra force, right? Downward gravity is there, but the force is constant. If you displace it by x, the excess force will come from the spring. So it will not come from gravity. Gravity does not contribute to time period. So for this, first of all, I'll put g equal to 0. And then first, let us look at the first question. This force constant is k, and this is it, and this. Now, if you pull it down by x, the extra force is F. Now, if you pull this down by x, then this pulley will go down by how much? X by 2, right? Because see, I will explain it from a different viewpoint. Suppose this pulley goes down by a distance h. So this pulley goes down by a distance h. So to keep the length of the rope constant, this 2h length of the rope will come down, right? So 2h length of the rope will come down. So that means if it is x, then the pulley will go down by x by 2. Pulley goes down by x by 2, and the mass, so as the mass goes down by x, so that means the force is kx by 2, and tension in each string is kx by 4. You know, half and half will be half of this force is distributed on either side, because it's a massless pulley, so tension should be equal on both sides, else there is unbalanced torque. So those all things are there. So that means the net thing is that means you displace this block down by x, there is a force kx by 4 which is acting. That means I can write that mass times acceleration is minus k by 4x. So therefore equal to minus k by 4m into x. So the time period, as you know, is 2 pi root over of 4m by k. This is for the first problem. Now let us look at the second problem. Now for this second problem, if this mass goes down by x, so this pulley goes down by x. So as you know, the whole of this string and the spring, the increase in length should be 2x, but you know, string length doesn't change. So the spring length will increase by 2x. So that means this is 2kx. This tension is also 2kx, and tension in the in this string actually, or rather leave that string out. So if you take the whole of this pulley, the total force on this pulley is 4kx. That means the restoring force, and this pulley and this mass, take it as a one system. So as it goes down by x, 4kx. So therefore I can write mass into acceleration is equal to minus 4kx. So therefore this is minus 4k by m into x. So therefore this time period t dash is 2 pi root over of m by 4k. Hopefully it explains the question.